now in third year. The thing is, this course that we're looking at, firstly, object-oriented programming, is a continuation of the introduction to programming that you did for C++. It's basically a continuation because you ended on functions in programming last year. So that is now a continuation from where you ended. Now, this continuation is going to include everything that you did last year. So meaning you are basically required to come with that foundation from last year and apply it in this course. So this is just a continuation. So what we'll do, we will look at this course nicely. Of course, time has gone and months have passed, so it's normal sometimes to forget some things here and there. But you will notice as we go on, things will slowly start to come back. It's just a question of jogging your memory. So let us first start by defining what this course is, object-oriented programming. You will notice there, it says object-oriented programming. I think programming, you understand that, but programming is the process of writing instructions which a computer has to follow, right? A computer has to follow. When you build an application, that process is called programming. But when you use object-oriented programming, you know, this is now a specific type of system that you use for writing these programs. Like, let's say, for example, when you say you learn via Zoom, that system of learning is online learning, right? Then when you learn in class physically, that one is, of course, called physical learning, okay? So both things are a form of learning, but the only difference is one is based online, the other one is based physically. So even object-oriented, it is a type of programming. It's a system of programming. Now, this system of programming, it is based on what are known as classes and objects. Throughout this entire course, you will be dealing with classes and objects. Classes and objects. So I think if you've noticed one thing throughout ICT, this program, ICT, foundation is very important. Once you've established a strong foundation, once you've understood the concepts, it is very easy to apply anything going forward. So it is the same here. This is where everything is very, very critical. Your performance in December is based on what you're going to pick between now and August. This time is very critical because this is where you're going to form a strong foundation. So I'll do my best to help you. And then you should also do your best to also pick the concepts. So object-oriented programming is a system of programming, okay? So object-oriented programming is a system of programming So this is a system of programming that is based on the concept of classes and objects. For now, just don't worry about understanding a class and an object. We will understand what a class and an object is as we go on. So we will understand what a class and an object is going forward. I just noticed that questions. Okay. So this system is just based on classes and objects. For now, don't worry. You can see there in question 3, we are addressing what a class and an object is. But what you need to know is that object-oriented programming is based on classes and objects. So when you are dealing with this course, you'll be dealing with classes, objects throughout until you finish in December. That's how it works. Now, question 2, it says, explain the main features of OOP. Explain the main features of OOP. You know, when you ask yourself, what are the main features of Zict? Or is it Zoot now? It's Zoot. The main features of Zoot. Obviously, you say, well, Zoot offers ICT programs such as ICT with education, there's BIT, there's cybersecurity, and then they also offer business administration and other business courses. Those are the features of Zoot as an institution. So now we're trying to look at the features of object-oriented programming. What are some of these features? So we're going to look at these features now. We are going to look at these features now. So the features of object-oriented programming. So the first feature that we can address is code encapsulation. Encapsulation, this is a term which simply means to enclose into one single unit. Okay, so if I get a small box, and then I get pencils, I enclose them in that small box. That is a form of encapsulation. If you've noticed, there are medications known as capsules. Mostly they come in the form of antibiotics. They're called capsules. Why they're called capsules is because inside of them, there's a powder that is enclosed inside. Capsule. So they are encapsulated with a powder. So the process of encapsulation simply means enclosing data into one single unit. That's what it means. This is one feature of OOP. Because what a class does is it gets data and encloses it into one single unit. What is this data? You get all your functions, you get all your arrays, you get all your for loops and if statements, then you enclose them into one big container. That is known as encapsulation. So process of enclosing data into one single unit is what we refer to as encapsulation. So the process of enclosing data into one single unit is what we are referring to as encapsulation. The second concept that we have is called inheritance. The second concept that we have is called inheritance. Okay, inheritance. Inheritance on away from ICT and programming and technology. Let's talk on a normal layman's level, human level. Inheritance, especially where families are concerned. If you've got a father, that father maybe he's built homes, he's got houses, he's got companies. When he has children, be it sons or daughters, those children, after he passes on, those children will be able to take over his wealth and run it. That process of taking over is known as inheritance. So children acquiring the wealth from their parents and using it as their own now is what we call inheritance. So OOP has this feature whereby data which is enclosed in a class or in several classes, this data can be exchanged and inherited between several different classes. It can be inherited and exchanged between several different classes. There are some terminologies, in fact, that we are going to find as we go on, which actually suit our normal human day-to-day life, such as parent class and child class. They exist in OOP. That's why this concept of inheritance is there. So inheritance is the process in which classes are able to acquire data from one another. Okay, so the process in which classes are able to acquire data from one another. Okay, the process in which classes are able to acquire data from one another. So that is the concept on inheritance. So far, are we moving together? If you put a question, I'll pause here so that you can pose some questions. I just want to make sure we are together. You know, when starting, we need to move together. Mr. Alfred, are we together? Is everything going smoothly so far?
We are, but shed more light on inheritance.
Oh, inheritance. All right, very well. So inheritance, I did speak on classes. We have not defined what a class is, but I'll give you a brief idea of what a class is. A class is something that you declare within a program. Now, when you declare a class, it contains several different types of data inside. You know, you can close different functions, different if statements, and different loops. Yeah. Now, what happens is this: you have several different classes in the same program, right? Several different classes. So these classes are able to share data amongst themselves. And that is the process that we are calling inheritance. Classes having the ability to share data amongst themselves. That's what we're calling inheritance. Is it okay now?
Okay.
Okay. Madam Cleopatra, are we good?
Yes, we are following.
Okay, okay.
Yeah.
Have you started doing this course in class, by the way? Have you started?
We did it. Now there was nothing like introduction. Just what did they say? It was just comparing C++ and this same one, the differences. From there,
Okay.
From there, he said we should download something like a Python charming, PyCharm, so that we start doing the programs. But the explanation of the classes, what are objects, the inheritance, he didn't say anything. He said he cannot explain such.
Wait, he said
So
you need to download PyCharm. So if he said you need to download PyCharm, that means you're no longer doing C++, you're doing Python, is it?
yes, he said we'll be using Python, not C++.
So you've done all of it.
Yes, said Python is a bit flexible. And
I think it was you, Mr. Alfred. I think I wrote you a message. That was last night. I was asking that you need to find out which programming language you'll be using. You read my message, huh?
We'll be using Python.
Okay.
We'll be using Python.
Okay. So you've never done Python before. So
no.
Which means for today, we'll look at the concepts of OOP. And then I'm going to show you how Python is. Have you downloaded Python already on your computers or not yet?
Yeah, for me, I've done that, but the only thing that I've not downloaded is PyCharm.
PyCharm, okay. I know PyCharm, it's just like code blocks. It just helps you to write code. It's just
okay.
Yeah. Okay, thank you. Because I think I had that feeling because times have changed. Most schools are no longer doing C++. So I also sense that maybe you in your school have stopped. That's why I had to write that message to Alfred. I asked him if you're still doing C++. So now that we know that we're no longer doing C++, then we'll focus on Python. But otherwise, the concepts are the same. The features of OOP that are in C++ and Python, they are the same. The only difference is Python and C++, they differ the way they're written. They're not the same. But in terms of encapsulation, inheritance, they're also there in Python.
Okay.
Yeah. So, yes, we just do this. Because if it's doing Python, we need to start from scratch. I cannot just go straight to Python classes minus me showing you how to write hello world in Python, a function in Python that you don't know yet. So we have to start from scratch. What we shall do, let us do this. Question 2. Let's do this. Just a question too, because I was not aware that you're doing Python, so let's just do it. So, I want to give you a background of Python, just to understand the syntax and the rules. So today we'll just look at what Python is and how it works, because the rules that are there in C++, they're different compared to Python, as you see. Okay. So question 2, you just edit it like that, but with the features, no problem, we can continue. So the next feature that is there in object-oriented programming is known as polymorphism. When you look at this word, polymorphism, there's this term poly. Poly in English means many, as in polygamy, many wives. And then morphism means forms. So polymorphism means many forms. So this is the ability for a program to present data in different forms. Because what classes do, they can present data in different forms. Maybe let's say you've got a number 4 as an integer. It can be represented as 4.0 in terms of a float or a double, right? So that is a form of polymorphism. So the ability of a program to present data in different forms, present data in different forms, present data in different forms. Then the fourth feature, of course, is code abstraction. The fourth feature is code abstraction. Mr. Albert, what does it mean when something is abstract? What does it mean when something is abstract? What does it
mean? Repeat.
Abstract. When something is abstract, what does it mean? When something is abstract, somebody tells this is abstract. What does it mean?
I cannot explain it, sir.
Okay. So if something is abstract, it means you basically hide what is irrelevant and you only present what is relevant. Like, for example, you look at the way, the way we learn together, my teaching style. I really like to focus on what is relevant at that particular moment, like overloading you with information, right? Because when you look at programming as a whole, it's very rich. But what we do is we'll just pick what is relevant at that particular moment. Like in this case, we are introducing. So we are only picking the introductory part so that you understand what object-oriented programming is. Then you also understand what type of a language Python is. So that is a form of abstraction, whereby you hide complex information and you only present what is needed at that particular time. So OOP programs have that ability. They can present you with data that you need at that particular time and hide everything else. You find that you've got a very big program with many different classes. But you can tell your program that I only need information from this class. So it will apply this method of abstraction in which it will say, okay, I've got 50 classes, but the user only wants information from this one class. This is what we call abstraction. So the ability of a program to hide complex data and only present relevant data is what we are referring to as abstraction. So these are the 4 features of object-oriented programming. These you need to memorize because they always come in every single test that you write for OOP. They always come. You always find them. You cannot run away from these. you always be asked to define them. So please use to memorize them. We can copy if we've got questions, we can ask. So that question 2, we now begin to.
So there are only 4 features of OPP.
Yes, therefore.
OOP.
OOP, yes, OOP. Therefore.
Okay.
Yes, therefore. So please memorize them. Memorize these. Okay, capture. Yeah, capture. We done? Can we proceed? Are we done?
Proceed.
Okay. Let's look at question 2. It says write a program in Python to display I am a developer. Just to display this.
On question 1. On question 1, I've not done number 3.
Oh, sorry. Okay. Thank you. So it was on an object, huh? So we have to define what is meant by a class and an object. A class and an object. So firstly, let's start with a class. A class. So we have described the features of OOP. And OOP in itself, we have said that OOP is based on classes and objects. It is based on classes and objects. Now, we don't need to understand what a class is. We need to understand what a class is because you keep on saying class, class, class. What is it? Okay. So a class is referred to as a blueprint of a program that serves as a container for the data accessed using an object. Then an object, I'll define them double so that it's made easy. So an object is so a class, we're saying that it is a blueprint of a program which serves as a container holding data accessed using an object. What this simply means is this. I'll give an example of an actual classroom. An actual classroom. So an actual classroom, it is a room that is built, using bricks and ceilings and doors, right? So that classroom, you find students, you find educational material, different things. Okay, that is the data we're talking about. So the class itself is a room. Now, when that room is locked, obviously you're going to need a key to open the door to access that classroom. To access that classroom, to unlock that classroom, you're going to need a key. So an object is more like a key. It is a key that is used for accessing that class. Okay? Without an object, you cannot access what is stored within a class. So a class is just a container which holds different types of data. It holds data. Okay? But that class cannot be accessed without an object, because an object is called a key. Okay, it's a key that is used for accessing class data. Without an object, you cannot access anything that is stored in a class. This is why an object is also known as an instance of a class. So an object is also known as an instance of a class. These are very technical terms, I know, but all you need to know is that a class holds different types of data, and you basically use an object to access stored in that class. Are we moving together? It's clear so far. Is it clear so far? Alfred, together?
What is a blueprint? Blueprint.
A blueprint. A blueprint, we can say, it basically describes the structure of that particular container. Okay, something that just describes that structure of a particular container. So it just shows you how that container holding the data is. That's what we mean by blueprint. Okay. Or if you do not want to use blueprint, you can just say a structure of a program which serves as a container. It is just a structure holding data, a container holding data, okay, enclosed in one single unit, okay? Another term, we can say